Okay, we'll be continuing 1.3 today, and then we'll save the applications for tomorrow where it says solve real life problems. We will hold off on that until tomorrow. Okay, so we're going to focus on continuing to write linear equations in two variables, a few more variations of that today, and then taking a look at the relationship between slope and parallel and perpendicular lines. Okay. All right, so let's go to example 10, where we left off yesterday. Example 10. All right, so use the given conditions to write an equation for each line in point slope form and slope intercept form. We're not going to worry about general form right now, okay? So you can just forget about that. Not going to do that. It's not on the quiz. All right, so this is how 10's a little bit different than 9. 9, they came right out and gave us the slope. Okay, if they don't come right out and give you the slope, we can figure that out on our own. Okay, just like we did on 5 through 8. All right, so I don't think we need to do two of these, so I want you to start this by finding your slope first. So I'll let you get a little ahead of me here. Find the slope. Once you have the slope, then you just pick one of these points. Okay, eeny, meeny, miny, mo, it doesn't matter. Grab one, and then you can continue to write your equation of your line. Okay, so go ahead and do that. Okay, so we should have a slope of 1/2, 3/6. And now just pick one of these points. So it's up to you. You could have either of these two equations. Okay. Now, when you solve both of these for y, we end up getting the same result. Kind of just magically works out that way. I'm just going to do the work for this one. So I have y minus 8 equals, distribute to 1/2. I get 1/2 x. Half of 4 is 2. Okay. Add the 8. Does have any questions for me on that? Okay, so we'll skip 11 for now. I think 10 was enough. Let's move on to the relationship of parallel and perpendicular lines. Okay, so two lines are parallel. Now you don't necessarily have to write this if you want to, but when I'm referring to M1 and M2, it's just slope of line 1, slope of line 2. Okay? So two lines, if they're not vertical, the reason why this says not vertical in here because there's an exception to the rule with the undefined situation there. Okay? So two different non-vertical lines are parallel only if their slopes are equal. Okay. They will be parallel only if their slopes are equal. All right. So if you wrote the equations down, this might make sense. If not, maybe you don't need this part. M1 has to equal M2. The number's in front of X. Okay, what about perpendicular lines? This is also in your book on page 27 if you want to reference that. This isn't enough. You can read their explanation there as well. Okay, perpendicular lines. Once again, we got to get rid of the undefined situation. It's a little exception to the rule, but as long as it's not vertical, so two non-vertical lines are perpendicular only if their slopes are negative reciprocals of each other. In the book, we'll show it this way. Take one slope. If you take the other slope and do 1 divided by that in your calculator, they should be equal. It's kind of students don't tend to like that way. I get it. Basically, just the idea of reciprocal. If I have a fraction a over b, right, its reciprocal is just going to be b over a. Flip it over. And they have to be opposite signs. So if this is starts out a negative, then this needs to be a positive. So they have the negative or opposite reciprocals of each other. Okay. All right, so with that being said, we'll be able to try the next example. All right, quite often too, for short, if you want to represent parallel with these slanted lines, go ahead, upside down capital T for perpendicular, or maybe neither in this relationship of these first two lines. So here's what we need to take a look at. What's the slope? These are both solved for y, so we can quickly identify the slope as 3/4. I call that M1. And this is the slope for the second line, -4/3. Most of you can look at this and you understand the reciprocal idea. These are opposite reciprocals. That means they're perpendicular lines. If you wanted to use what the textbook is doing and check your calculator, you could do 1 divided by the second slope in your calculator, change the sign, and then you get 0.75 for both of them. Okay, so yes, they are perpendicular lines. All right, pause if you need to write that down. All right, so you're going to try 13. You just need to realize that you got to solve L2 for y. So solve L2 for y and then compare the slopes and make a decision on parallel, perpendicular, or neither. Okay, go ahead. Okay, so solving this for y, subtract the 8x, we get this. Divide both sides by -2. We get this. And there's the slope we're looking for. So this has a slope of 4, and so does line 1 has a slope of 4. Since they're the same, our conclusion needs to be that these are parallel lines. Right. Okay, moving on to example 14. I'll give you some steps to fill in here for the success criteria on this type of problem. First step, what I want you to do is find the slope of the given line. Okay, find the slope of given line. Once you do that, we need to consider or find, I'm going to just put M for slope, find M for the new line. And at that point, we'll kind of talk and discuss. We'll realize that we have a point that's given to us in the directions up above here, and we'll have the slope. So we want to use point slope to write the equation. So use point slope form to write equation. Okay. All right, so looking at these directions, it's going to say find the slope-intercept form. Notice I didn't put that here. It just depends. It might say keep in point slope form. But if it says slope-intercept, we know what in the end we're going to have to solve that for y. Okay, so that'll be our fourth and final step now for this. Now it tells us that the line passes through this point, and it's parallel, though, to this one. Okay, part B will be perpendicular. So for part A, it's parallel to the line 5x minus 2y equals 3. So for step 1, we need to find the slope of the given line. So step 1, this is the given line. Let's find the slope. Okay, so solving for y will help us do that. It's hard to see the slope right now until I solve it for y. So let's move 5x to the other side. I'll put the x term first. If you did 3 minus 5x, that's fine. Just make sure you know that the slope is in front of x every time. All right, so that results in y equals 5/2 x minus 1.5 or minus 3/2. So now we've identified the slope of the given line. It's 5/2. Okay. Okay, so for part A, it says, all right, now we're supposed to write an equation of a line parallel to this one. So if it's parallel to the old line, it's got to have the same slope. So for part A, you got to think about my given information, right, or my collected information. Slope, maybe you shouldn't say given, I should say using. whatever. Slope of 5/2 and our points, negative 1, 2. And then this is a review problem from yesterday. We've done this now. Okay, so they kind of indirectly give you the slope. You have to figure it out knowing the characteristics we went over today. Y minus my y coordinate equals m times x minus a negative 1. The directions do say slope-intercept form up there, so we need to go ahead and solve for y. Five halves times 1 is 5/2, but we want to change it to a mixed number, just a little bit easier to deal with when I add the 2 over, or 2.5. And now let's go ahead and add the 2 to the constant term. Any questions on part A? Okay, part B. Now we just got to realize that they're changing the word to perpendicular. If it's going to be perpendicular to this line, which has a slope of 5/2, we got to realize that the perpendicular slope is going to be negative 2/5. Okay, opposite reciprocal. And then we're still using the same point. It's still supposed to be passing through the point negative 1, 2. So we have this and negative 1, 2. All right, I'm going to pause here and let you set it up and solve for y and see what we get. Any questions on getting the slope? Okay, so we found the slope of the given line, 5/2. Now we found the slope for the new line. For b, it's negative 2/5. Finish it by using point slope. There it is. Got a little tricky with the fraction work over here. I'll try to quickly explain. Distribute the negative 2/5 we get here, and then add 2. Some of you guys can do that in your head because you're good with fractions. You understand 2, take away 2/5. I have 1 3/5 left over. But let's just say you wanted to work towards a common denominator. Here's what I'd recommend. Kind of going off to the side and doing something like this. 2 over 1 is 2, and then I'm subtracting 2/5, right? Those are not common denominators. So you could multiply this by 5 over 5 to correct that, and you get 10/5. Take away 2/5. Now the denominators are the same. I do 10 minus 2, and I get 8/5. Okay, and that's our y-intercept. I change it to 1 3/5 in my answer, but if you kept it as 8/5, that's fine because it's reduced. So I'd accept either one of those. Try to keep things in fraction form when you can. They're more accurate than throwing in decimal form. If it's multiple choice, I'm probably going to have it in one of these two forms, okay? So there it is for the y-intercepts. Calculators can help too. If you punch that in and hit math, change to fraction, gives you 8/5 right away, okay? Okay, so 15, it's very similar to this, another version. Maybe I'll use it as a warm-up one of these days, but for now, I think this is enough.